Greetings everyone! Back on the bench is the Carver m400t amplifier. If you follow my channel, you might recall that I had two of these. I had an m400 and the m400t. They were given to me for free. They didn't work, so I serviced them, got them going again. The m400 is somebody else's now. It belongs to somebody else. It's good to keep these vintage electronics working and out of the landfill. You know, people can enjoy them. But the m400t, I serviced it, put it back together. It was working, but I noticed it had a problem. When you cranked it up to full power, I noticed one of the high rails wasn't working. It was the negative side. I think it was this board here. So these amps, when I first got them, they were just full of bad capacitors. So I replaced all the bad ones and some that measured good, but I replaced them anyway. Especially these large high rail filter caps. They were bad on both amps. And several on the amplifier board on this amp. Interestingly, the m400 amp, all the caps were good on its amplifier boards. All the problems were on the supply, but on this one it was mainly the amp boards that had the bad caps. But anyway, when I had it apart, I checked all the transistors, you know, just a junction test with the diode check function on the multimeter, and everything looked good. Because these things are hard to service. And I wanted to check, you know, solder joints and everything, resistors, much as I could. Because once they're back together, you know, they're kind of hard to tear down because everything plugs into this power supply board. There's like a socket, you can see down in there. It's all socketed. And because the transistor socket's set into this heat sink, you have to take all of the transistors and drivers loose, and the input has to come loose, and this has to come loose. That way you can back it all out enough to unplug the board. And unfortunately, the problem transistor, I believe it's this one, we'll check again on the scope. And I believe it's this one. It's set back in there. I can't get under it enough to work on it, so have to pull the board to service the amp. You know, with the bad caps and everything, I couldn't check that when it was apart. Another problem is these amp boards require 8 supply voltages. There's dual supply, low, mid, and high rails. And you know, that's 6 supplies there, and then the op amp requires a plus and minus 12 volt, so that's 8 voltages you need, and plus heat sinking and all that for testing. And you can't really test the board out of circuit. There might be some things I can do. We'll, might try that out, but well, anyway, let's hook this up and see if I can display the problem here on the scope. Okay, I got it all hooked up here. I still had those 1K resistors on the outputs. Something I can clip my scope onto and provides a light load. And the preamp and signal source. Ignore the voltage on the scope. I have the probe at 10x and the scope still on 1x. I'm just lazy, didn't set it. But anyhow, see how it clips on the bottom rail first? Because it's not working properly. When I scope the base of the driver on the high rail negative side of the amp, I'm getting a signal. So the amp is into clipping, so that signal there to drive that stage is showing up. But when I scope the emitter, there is no signal there. Okay, pulled all these transistors out, pulled the board out. Here's the schematic for the one channel of the amplifier. So I'm homing in on this section here. This is the high rail, or the high section on the negative side of the amplifier. You can see here's the high negative rail, and all the collectors are connected to that of the pre-driver, driver, and output. And the emitters are connected to the low rail on the negative side. The emitter of the output's connected to the other outputs because they're stacked. It's a Class G amplifier. The only other connection is here. This is signal. So it goes through this circuit, which sets the level of when this will cut in and supply signal to the output. So when the signal voltage reaches a high enough peak on the negative side, this will kick in and start contributing to the output. Well, this transistor here supplies the signal to the whole negative side of the output stage, and we know it's working. You see its emitters tied to the bases of the lower two output transistors through circuitry which sets their cut-in level. Well, the lowest one's always on, of course, but the mid-level transistor cuts in at a certain voltage. So this is okay, and you can see the high rail connects to its emitter as well. So we know this is okay. And I'm measuring signal. I'm getting that little signal right at the base of this driver, but nothing on the emitter. And this is interesting, as what we're going to see in a minute. So I want to try to operate that high rail negative side out of the amplifier to see what's going on. So it should work with low voltage. I just have 9 volts, negative 9 volts here, and I'm connecting the emitter side here on my power supply. So it's set to 9 volts, and I have a current limit so I don't damage anything. Then I'm injecting a signal on the pre-driver right at its base. I'm using the Field Tech. I'm putting in a 10 kilohertz square wave. And to connect the emitter back down to the supply, to complete the circuit, I've connected a light bulb, and you can see it's on. And it's got a little ring ding there, but this is a signal across that light bulb. So this is confusing because it's working. I'm getting signal through it. Well, yeah, I am getting supply voltage. When the board was in the amp, I was getting all the proper rail voltages. So why did I lose signal in the amp here, but it's going all the way through, and when I'm just running a little test here? Is it something with that signal level? Maybe I should check all these components, because yeah, even if I pull this transistor, the output transistor, the current will go through this 33 ohm resistor through the bulb. It'll be a little bit dimmer, but yeah, that transistor is working. This is slightly warm. So everything seems to be doing the business here. So I'll have to check these components to see what's going on. Well, I took the 121 gigawatts meter and started probing around the circuit here. And these two resistors are dead open. They're supposed to be 22K. And this side ties to the negative rail, the negative high rail. It's these two resistors, I presume. And it has to be. These tied to the negative high rail. And it's part of this commutation circuit. So why was I getting a signal that stopped here? Maybe it was just too weak. It wasn't enough to drive that transistor. I've never seen anything like it. They're not burned or anything. And they're pretty high value resistors. I checked the foil side. Let's see, where's my probe lead thingies at? So they're right here. See, this is the collector of the output, which is the negative. You know, it's tied to the negative high rail. And it goes right here. And that's one resistor, that's the other. They go right across there because that's the transistor that they're next to. Right there. You can shine a flashlight up through the board and see it. I don't have enough hands to do it here with the camera, but yeah, open. Diodes check out, the other resistors check out. Some of them read a little bit low because, you know, this is 2.2K and it reads 1.6 because, you know, you got loops of resistors here, so it's going to make it read a bit low. So yeah, I guess the transistor is okay because it worked with that other test. It's just what's going on before the pre-driver here. It's open. Well, I'm going to warm up the iron and replace those bad guys right there. Okay, I have the replacement resistors installed thanks to Radio Shack. I bought them from Radio Shack years ago. They're finally getting use. Pile in the car, kids. We're headed for Radio Shack. Yay! But looky here. They're open. There's no signs of burning or any damage. I must admit I've not seen that. Any resistor that I've measured that was open was fried to a crisp. But yeah, that is a weird one. Now, I wonder if that could be a failure mode with a reasonably high voltage across them and a fairly high value. You know, these are 22K. Maybe they can just quietly fry open or something. I don't know. Just a thought. Okay, about a half hour later, got it all assembled. Bring it up on a limiter. You don't want to do all that work and have it blow up in your face. Seems to be clipping symmetrically now, but we'll take it off the bottle here and see how it works. Okay, it's off the bottle now. All the way to clipping. Look at that. No more early clipping on that one channel negative rail. Okay, the other channel is working. Now I'm doing both channels driven test. 8 ohms. Let's give it hell. Wow, does that thing... Listen to that thing buzz under high power. Putting out 30 something volts. Let's see, 38.44 volts. Uh-oh, it stopped working. I think I blew the fuse again. Just like on the other amp. I put those 8 amp fuses in. And I can't do it with one hand. Okay, yeah, popped a fuse, I put a new one in. So how much power does this thing draw? I don't know if you can see that there. And that's that clipping. that's volt amps. It's over 1,000 watts, or volt amps actually. It's got a weird, it's kind of like a line frequency switch mode supply using a triac to regulate the voltage so it doesn't sag under load as much. That's one of its tricks to help keep the power up. I think it's quite warm after these tests. Okay, it's all reassembled. It's in pretty good shape. Not a lot of dings or marks. I mean, I gotta clean the heatsink grease fingerprints off, but it's good. Okay, how about some YouTube lounge jazz? Surprising how quiet it is, despite having a triac inside of the amplifier itself, chopping up the AC waveform. You know, it suddenly turns on during the waveform to regulate the voltage. In fact, most of the noise comes from the amp itself. You can hear it buzzing, but they managed to keep it out of the audio chain pretty well. But anyway, that's going to wrap it up for this. Another one saved from the dump. The Carver m400t magnetic field power amplifier. Okay, catch you in the next one. Thanks for watching.